have had any kind of an equal sign in them. They've all just been expressions. So today we're actually going to have equations. So we're going to have equal signs, and ideally what we want to do anytime you solve a quadratic equation, if you're going to do that by factoring, you want to set it equal to 0. So what I have at the top just says ax squared plus bx plus c equals 0. That's important. What we're going to use that's going to make that important is called the zero product property. This is kind of bizarre the way this is the actual definition, but I'm going to explain it to you in a second with some examples here that are quadratic. But if you have two things multiplied together, and it could be 3 things, 4 things, 5 things, but if I have 2 things, I just have p times q equals 0. If you have 2 things multiplied together to give you 0, either p has to be 0 or q has to be 0 to make that happen. So if I got 2 things multiplied together to give me 0, one of them has to be 0. Both of them could be 0, but at least one of them has to be 0. Okay, so when you solve a quadratic equation, oftentimes what they call the answer is a 0, or I feel like these words are very interchangeable and I don't really stick to one or the other, so we use both. So this is also called a root of a function. In general, not just for quadratic, but any 0, any root for any function, it's just the value of the variable that makes the equation equal to 0. Most of the time that is a value for x that would make the y value equal to 0. If you have a word problem or something like that, it might be different variables, but it's the x value that would make the y value 0 in general. Now on a graph, it's where the graph crosses, actually let me add into this, crosses or touches the x-axis, and we're actually going to see that where it touches the x-axis in one of the examples I'm going to do with you in a second. But basically anywhere the graph would interact with the x-axis is a 0, or also called a root, and that's what we're going to find today when we solve these equations. Okay, here's the deal. These two equations in example 1 are 2 sets of factors, just like we were doing yesterday. This one's 2 factors set equal to 0. This is like a greatest common factor times another factor equals 0. So based on that zero product property, either this x minus 5 needs to be 0, or x minus 3 needs to be 0 to make that true based on that property. You don't need the parentheses. I honestly don't know why I just wrote those parentheses on there. If you just solve this little teeny tiny equation, right, I would just add 5. So if x was 5, right, if you come back here, you plug in 5, that first little set of parentheses would be 0. This would be 8, but 0 times 8 would be 0. So one of your answers there would be 5. The other one, you don't need these parentheses. I really don't know why I just wrote those. You just add 3. So your other answer is actually going to be 3. If I plug in 3, that first set of parentheses would end up being -2, but the second set would be 0, so anything times 0 is 0. So it's 2 answers to this question. All right. In this case, you just have a greatest common... Uh-oh, what did I do wrong? Oh, it was a +3, so we should subtract 3, fail at life. Okay, sorry. X is -3 was the other one. Sorry, guys. All right, now, this one's a little weird. If you just have a greatest common factor, okay, that 4x, if that was equal to 0, that would wipe the whole thing out. What would x be in that case? 0. And so 0 can be one of your answers. Now the other one, you have 2x plus 9. If that was 0, that would also give me another solution. Now, I don't usually write this out. I'm going to on this question, but I usually just kind of talk myself through. If I set that equal to 0, what would I do? And we would subtract 9, right? And then you'd divide by 2. And so my other 0, or my other root, would be -9/2. I don't usually like write out a bunch of work for these questions. Like if I did this first one again, I'd be like, okay, what I plug in for x to make that 0? If that's a -5, I'd plug in +5. If that's a +3, I'd plug in -3 to cancel it out. So you don't have to write out all that work if you can kind of figure it out without doing that. Now, the reason I had you guys do all this factoring is because we're going to solve these equations by putting them in that factored form, and we can use the zero product property. You can't go through, if you've got an x squared, a 7x, and a negative 18, you can't just go through and get x by itself, because these terms can't actually be added together. The x squared and the x, they're not like terms. So we have all these different methods that we're going to go through for how to solve this, and one of them is factoring. So if you guys remember from yesterday, and the day before actually, this is just, I'm going to multiply a times c. In this case, the a value is just 1. C value is negative 18. I got to find two numbers, multiply to give me negative 18. Same two numbers, add to get me 7 to help me factor this. Can you guys think of two numbers that would fit both of those requirements? Jacob, what do you think? You were thinking of the answer, yes. Okay, negative 2, it's got to be negative 2, positive 9. That would be what we call the factored form. So I'm taking it from standard form, which I can't solve, to factored form. If it's in factored form, we can just use this zero product property. So these two things multiplied together give me 0. Either this has to be 0, which we would plug in positive 2. It's going to be the opposite of the factor when you do this. And for this one, we would plug in negative 9. Negative 9 plugged into both of those would make the first little thing negative 11, but it'd be times 0. If you plugged in 2, it'd make the first one 0, and it'd make the second one 11. So one of them will be a number if you plug them back in, but one of them will be 0, so it'll cancel it out. The question right next to this, if it's not set equal to 0, which it's not, that is the very first thing you should do. And so I'm going to add 16 here. And in this case, it's not really an issue, but you should try to keep your squared term positive for any of these questions if you're going to try to factor. So you might have to move a couple things to another side, make a little bit more work in some of these questions, but keep the squared term positive if you have to move things around. So for this guy, I got to think of two numbers that multiply to give me 16, same two numbers, add to give me negative 8 to factor this one. Can you guys think of the two? This would just start with x and x because I just started out with the x squared. What two numbers multiply to give you positive 16, add to give you negative 8? Negative 4, negative 4. Okay, now, these are actually the same answer, right? So I could do x minus 4 squared. There's only one answer to this question, and that would just be positive 4. Now, the reason I have the little graph over here, I just wanted to sketch this so I could show this to you guys. If we actually graphed y equals x minus 4 squared, if you guys remember doing this in our last unit, I'm going to do opposite copy for my vertex, so be at 4, 0, and the a value there's just 1, so I'd go over 1, up 1, over 1, maybe up 3 if I could count. Look something like this. Now this is the case where the 0 is just where the graph just touches the x-axis. This question, most of these questions will have two answers. They should have two answers. If you only have one answer, which we do here, the reason for that is because the vertex of that parabola is going to be on the x-axis. So that's what's going on for that question. That's why it only has one answer. Most of these questions, I don't want to say all of them, but most of these questions should have two answers unless you're in this situation where you have just the vertex touching the x-axis. If we were to graph this, this would go through the x-axis at 2 and at negative 9. Okay, let's try a couple more of these. All right, so I have x squared plus 4x. I'm going to add 3 to the left side of that equation to set that equal to 0. And then if we can think of our factors, we can use the zero product property to answer this real quick. So I'm going to start each of my factors, x and x. Let's see. This one, I got to multiply to get 3, and I need the two numbers that multiply to 3 add to give me 4. Can you think of two numbers when you multiply them, it'd be 3, add them, you get 4? 3 and 1. So these are both positive, right, to match up with that quadratic. The actual answers, though, are what set those factors equal to 0. So negative 3 and negative 1 are the actual answers to the equation. If you were, and you can go back to the original problem. If you want to plug them into the original problem, they should make everything equal to 0. Now, these last two I put on here on purpose. So there's only two terms here. If you don't have all three terms, it might not be the factoring where we have the two sets of parentheses. So don't forget, you can take a greatest common factor out in front if that happens. So what do x squared and negative 16x have in common? X. All right, so what would you have left over if you took out an x? X minus 16. Okay, what would my two answers be there? Jacob, go ahead. Perfect. 0 here, 16 here. Do you guys see, if I put 0 into the original problem for x, it wipes out both of those terms. So 0 is one of my answers. And then if we put in positive 16, it's going to take that second set. We'd have 16 times 0, but that would still be 0 if we plugged in 16. Okay, now something we did not do the last couple of days that you can do here. You cannot do this with a variable. You can never do this with a variable. But if the terms have a number in common, you can get rid of the number. So for example, this one, 3x squared 21x. You cannot get rid of the variable ever. You cannot divide a variable on both sides. It doesn't work that way, but you can get rid of a number. These numbers are both divisible by 3. It is completely legal for me to just divide everything in that equation, including that 0 on the other side, by 0. So this is really x squared plus 7x. You don't have to do that, but I want to make sure you guys know that that is an option if you're working with an equation. Now, this is super similar to the question we actually just looked at. You cannot divide by x on both sides and cancel it out. It never works that way. You can't do that with a variable. I can take an x out in front as a greatest common factor, though. And then left over, I'd have x plus 7. There you have your zero product property. So x, just right out here, if this is 0, the whole thing's 0. Or if we did x plus 7, negative 7. Would be my answer there. Does anybody have a question? Okay, so if I did this next one, like literally the very first thing I would do, I would go, hey, I think all those numbers are divisible by 3. If you're working with an equation and it's a number, it cannot be a variable. You can't do this with a variable. You can do it with a number. Just get rid of that number. There's no reason you can't divide 0 by a number. Completely legal. This is x squared minus 8x minus 9. And then usually whatever you're left with is a lot easier to go ahead and factor. So in this case, can you guys think two numbers that multiply to give you negative 9 but add to give you negative 8? Hayden, what do you think? Yes. Negative 9, positive 1. So one of them's x minus 9, one of them's x plus 1. That's the factored form. If we FOILed that back out, it'd give us what we have right above. But we want it in factored form because it's so much easier to identify the zeros. Just whatever sets the little set of parentheses equal to 0. This guy would be 9. This guy would be negative 1. That's it. Then I have one more that I want to set this equal to 0. Again, keep your squared term positive. So in this case, I'm going to add the 22x to the left side. So I've got 2x squared plus 22x equals 0. I'm immediately going to notice both of those numbers are divisible by 2. So no reason we can't get rid of it. You can't do this with a variable, but you can always do it with a number. So I just get x squared plus 11x, 0 divided by any number, totally legal, but that's 0. And then I have a greatest common factor out in front, x times x plus 11. Should have two answers here. So x is 0 and x is negative 11. It's whatever sets outside there, it's just a little x. And then inside the parentheses, it's whatever sets the parentheses equal to 0. Okay, now you guys, I accidentally cut off a couple problems and I didn't mean to. So I'm going to try to use like as little space as possible when I do these two questions. And I'm going to tell you what, I'm going to just draw a line here. I'm going to try and do another question with you because I don't have a problem like we were working yesterday with the Berry method. So I'm going to add a problem. These are not hard at all, I promise. It's a quadratic proportion. So do you guys remember how to solve a proportion with cross products from Algebra 1? Okay, so I'm just going to multiply what's diagonal from each other. Let me come up here. So one of them I'd have x times x minus 7. One of them I'd have 5 times x minus 4. So just a little distributive property here on both sides. I'm going to get x squared minus 7x equals 5x minus 20. Now, I end up with a quadratic equation because I have an x squared. What I want to do is set this equal to 0, but you want the squared term to be positive. So, and it just kind of depends, but it's just going to be, we want to move the 5x, which is positive, and I want to move the 20, which is negative, to the other side. So I'm going to subtract 5x and add 20 to the other side. When I do that, I'm going to get x squared, negative 7x minus 5x, we're going to get more negative, be negative 12x, and then I'm going to add the 20. Then I'm just going to ask you if you can think of two numbers. When you multiply them, you get positive 20, but when you add them, you get negative 12. X minus 10 and x minus 2. Negative 10 times negative 2 is positive 20. Negative 10 plus a negative 2 is that negative 12. Now, my actual answers, 10 and 2. So when you're working with the quadratic proportion, we're just going to cross multiply, set them equal to each other, and then set it equal to 0. So I'm going to practice just one more here real quick. So I'm going to have x times 2x plus 10. And then we're going to have negative 12 times x plus 4. And it doesn't matter which side you put those on. I just put the quadratic side on the left on both when I did this. But I'm going to get 2x squared plus 10x equals, over here, negative 12x minus 48. And again, you want to set this equal to 0 before you set up any factoring and keep your squared term positive. So I'm going to go ahead and add 12x and add 48 because those both ended up being negative. If we do that, we're going to get 2x squared plus 22x plus 48 equals 0. All right, if you're looking at that and you're like, hey, all those numbers are divisible by 2 because they're all even, perfect, get rid of it. Don't pull it out in front because it just makes it more work. Just get rid of it. You can divide 0 by a number. And then what we'll have to factor will be a little easier to work with. So this will be x squared plus 11x plus 24. And I'm running out of space. Can you guys think of two numbers that multiply to give you 24 and add to give you 11? 8 and 3. So one's a plus 8, one's a plus 3. The actual answers to the question are what set those little parentheses equal to 0. So negative 8, negative 3. Okay, now do me a favor. I just want to add a question, kind of like what we were doing yesterday, so we can just practice this one more time. So I'm going to add this here. I have 3x squared minus 11x minus 20 equals 0. So all the other questions that we've ended up factoring have ended up having just a 1 in front of the x squared. So let's just do 1 like we were doing yesterday just to practice this. So I'm going to add this question in. All right, so if I'm going to factor this, and I will not give you anything that you can't factor and ask you to factor it, that would be mean. So I'm going to take the first term and drop the squared, put that at the beginning of both of the factors. You have to multiply a times c. So first coefficient times the last. 3 times negative 20 is going to give me negative 60. And I want to add to get the number in the middle that's attached to the x, which is negative 11. Can you guys think of two numbers when you multiply them, you get negative 60, and you add them, you get negative 11? Say that one more time. There you go. Okay, if we do negative 15 times 4, that's negative 60. Negative 15 plus 4 is negative 11. All right, so one of these I write a minus 15. One of them I write a plus 4. But remember, if you have that number in front of the x squared, this is not the correct factored form. One or both of these will not be the real factor. For mine, the one I wrote first is not the real factor because both of those are divisible by 3. The real factor would just be x minus 5 because both of those are divisible by 3. You just disappear that out. Then the 3x plus 4, those don't have anything in common. And I'm just going to do a quick spot check. X times 3x is 3x squared. Negative 5 times 4 is negative 20. We should be good. Okay, here's how I do my answers here. This one, x minus 5, positive 5. if you've got a number in front of the x, like I do here, 3x plus 4, it's going to be a fraction. I literally just say to myself, okay, if I set that equal to 0, what would I do? And then I say, okay, I would subtract 4, and then I would have to divide by 3. If you want to actually write it out, you can definitely do that too. Just take whatever's in the parentheses, set it equal to 0, and solve it like a little bitty equation, because that's going to give you your 0. And then you would get the exact same answer. I just kind of try to do it in my head a little bit, but you can do it either way. And I'm going to have one tiny thing left for you guys to try and do, and that is for me to give you a 0 and see if you could tell me what the factored form would be. So if I have a quadratic equation, and my two answers, one of them's 2 and one of them's -1, could you tell me what the factored form would be? So if my answer, one of my answers is 2, what factor would go with that? -2. So you'd have like an x minus 2. If my answer, one of my answers is -1, what factor would go with that? X plus 1. That's all you have to do. Done with that question. Now, if my answer is 0, how would I represent 0 as an answer? Just an x. Yes, just an x and then x minus 5. And I'm just setting it equal to 0 because it says it's a 0 of the equation. Now, the last one is probably the trickiest because it involves a fraction here. What would you write as the little factor that would go with 4 being an answer? If 4 is an answer, 4 is a 0, what little factor would you write? X minus 4. Okay, now, this one's tricky, I think. How would I write down if I, say it again? 2x. Yes, so it's 2x plus 3. Now, if you guys are like, what the heck, where did he come up with that? You're just kind of like working it backwards. First of all, whatever the factor is going to be the opposite of the 0. So if it's positive 4 is the 0, you're going to have a minus 4 as the factor. If this is a negative fraction here, then it'll be a positive. So the x will be attached to whatever is in the denominator, and the numerator is going to be whatever you're adding or subtracting. In this case, since that was negative, I knew it was going to be plus 3 and then the 2x. So the variable, if you get a fraction, the variable will go with the denominator, and the numerator will be whatever you're adding or subtracting. Okay, now all this says in the last question is write the example from part C in standard form instead of factored form. Okay, so if I know this is the factored form, how would I write that in standard form? Like, what would you do to it? How would I change that from factored form to standard form? Multiply the 2. Thank you for raising your hand, Liam. That's so awesome. You're just going to like FOIL or box. That's all it means. All right, so you get 2x squared plus 3x minus 8x minus 12. So 2x squared minus 5x minus 12. So just ask you to do that for that one question. But if you have factored form, to get standard form, you're just going to do like a FOIL or box. Just multiply it out. Factored form is ideally what we want if we're identifying the zeros, because you can use that zero product property. Does anybody have a question?